The engine was already running rough before the aircraft ever left the ground. Not violently, not enough to abort the sortie under standing orders. Just enough to be noticed by ground crew who had seen too many failures begin exactly this way. The sound was uneven, the vibrations slightly off from what manuals described as acceptable, yet still within limits that allowed the machine to be cleared. In wartime conditions, limits mattered more than comfort. The aircraft taxied, lifted, and climbed, carrying a problem that doctrine assumed would soon resolve itself or become irrelevant in combat. In the air, engines were expected to perform because they had to. There was little room for nuance. Either a power plant delivered rated output across its band, or it was marked unreliable and replaced when resources allowed. Between those two states existed a gray zone rarely discussed. Imperfect engines that still flew. Machines that worked not because they matched specification, but because someone quietly stopped trying to force them to. In that unscripted space, the outcome of missions often shifted without ceremony. Under pressure to standardize, armies simplified mechanical truth into categories. Serviceable, damaged, unfit. The engine in question fell into none cleanly. It did not fail catastrophically. It did not meet expected behavior either. Carburation fluctuated. Manifold responses lagged under certain conditions. Temperature profiles drifted during climbs others considered normal. The assumption was always the same. The solution lay in replacement, not reinterpretation. But replacement required time. Time invited losses. Pilots learned quickly which machines could be trusted beyond doctrine. This knowledge did not pass through reports. It was exchanged on aprons, in hangars, through offhand remarks and adjusted habits. An aircraft marked marginal might still be flown by someone who understood it differently, not by fixing it according to standard procedure, but by changing how it was treated. Power settings altered, throttle movement slowed, climb rates moderated, cooling cycles extended. Nothing dramatic, nothing heroic, just a quiet refusal to operate the machine as if it were ideal. This kind of adjustment was not encouraged. It sat uneasily beside formal training, which emphasized uniform behavior across fleets. Engines were designed to be operated in specific regimes, and deviations were interpreted as misuse. Yet combat did not reward ideal use. It rewarded survival. The engine that survived was often the one not forced to prove itself. In Burma, in Alaska, across island chains where maintenance lagged behind operational tempo, these marginal machines accumulated. Fighters that others avoided were assigned secondary roles or held back. Until something changed. Not a breakthrough. Not a redesign, a choice. Someone stopped trying to extract full performance and instead preserved function. The aircraft flew slower, climbed differently. It did not chase enemies into regimes that strained its powertrain. And because of that, it kept flying when others did not. Once airborne, reliability mattered more than speed. A plane that could remain aloft and return mattered more than one that reached theoretical limits and seized. This logic ran counter to ideals of combat aviation, which celebrated engagement, pursuit, dominance. But engines did not recognize ideals. They responded to load, heat, stress, and imbalance. Under sustained operations, small changes compounded. An engine operated gently lasted longer than one operated perfectly. The friction lay between doctrine and reality. Manuals assumed fully functional components and control timelines. The war provided neither. In frontline units, power plants were pushed beyond refit cycles. Fuel quality varied. Ambient conditions shifted daily. Engines behaved differently not because they were poorly engineered, but because they were operating in environments their designers had not been allowed to imagine. Against this backdrop, an improvised fix emerged. It was not a part swap or an innovation officially logged. Carburetor mixtures were adjusted beyond recommended profiles. Ignition timing was set conservatively. Supercharger engagement was delayed. Cooling flaps were managed manually rather than automatically. These choices reduced peak output while stabilizing operation. Performance fell on paper. In practice, survivability increased. Higher command often dismissed such behavior as superstition or lack of discipline. Data favored standardization. Variations complicated analysis. Yet the aircraft kept flying. Sorties completed. Pilots returned. Maintenance crews noticed something else. These engines showed less internal damage. Bearings were evenly. Cylinders resisted cracking. Procedures deviated from doctrine produced measurable endurance. The contradiction deepened. The planes flown this way did not outperform enemies in classical engagements. They did something subtly different. They arrived when called. They stayed up longer than expected. They returned under conditions that grounded others. In dispersed theaters where rescue was unlikely, this mattered more than pursuit. The aircraft that flew when others could not altered operational planning in ways rarely acknowledged explicitly. Gradually, this behavior spread, not as policy, as habit. Power was managed carefully. Stress avoided. Pilots learned not to fight their machines. Engines were treated as systems with limits rather than tools to be dominated. This attitude stood in quiet opposition to romanticized views of aviation. Yet it worked. Commanders planning missions began to assign these aircraft to roles others avoided. Bad weather reconnaissance, long-range escorts at conservative speeds, ferry flights over hostile terrain. The airplanes performed steadily. Their engines did not seize. They did not require emergency landings at the same rate. Expectations shifted. Reliability replaced peak capability as a valued attribute. Enemy intelligence did not track this change. They measured speed, climb, armament. They did not account for endurance emerging from restraint. Engagement outcomes looked unremarkable. What changed lay beneath statistics. Airframes accumulated hours others did not. Pilots rotated through multiple missions instead of being lost to mechanical failure. This form of success resisted recognition because it did not align with prevailing narratives. Victory in the air was expected to be decisive and visible. Mechanical endurance achieved through compromise offered no spectacle. Yet in campaigns stretched thin, the accumulation of such quiet advantage reshaped force availability. Squadrons remained operational longer. Replacement rates slowed. The engine fix itself was mundane. No breakthrough metallurgy. No new component. Only a willingness to accept less than maximum output in exchange for consistency. In engineering terms, this was obvious. In organizational terms, it was subversive. Doctrine existed to create predictability. Here, predictability arose precisely by ignoring doctrine. As pressure mounted across multiple theaters, tolerance for deviation quietly increased. Commanders stopped asking why certain aircraft were not flown to specification. They asked instead whether they returned. Maintenance logs showed something unexpected. These planes required fewer emergency repairs. Failure modes shifted. Sudden breakdowns gave way to gradual degradation that could be managed. In time, formal procedures began to reflect this reality indirectly. Operating envelopes were broadened. Guidance grew flexible. But the shift had already occurred at ground level. It had been driven by necessity rather than insight, by the simple fact that someone chose preservation over performance. This did not render combat safer. Enemy fire remained lethal. Navigation errors remained fatal. But mechanical attrition declined. Aircraft that were once considered liabilities became reliable assets. Not superior, enduring. In retrospect, the laughter that greeted early deviation seemed inevitable. Any departure from doctrine is first interpreted as incompetence. Only results challenge that assumption. The aircraft flew. The engine held. Missions completed under conditions that grounded others. Gradually, the ridicule faded into quiet acceptance. What had changed was not technology, but the relationship between operator and machine. The pilot no longer demanded compliance with ideals. The machine was allowed to function within its actual limits. This balance proved more durable than domination. Under continuous stress, systems that were respected lasted longer than those pushed to prove themselves. Across the war, countless machines survived not through brilliance, but through restraint. Their stories rarely entered records because they lacked drama. Yet operational history is made of such stories, of decisions not to push harder, of choices that trade dominance for persistence. The plane that flew when others could not did so because someone accepted imperfection. In that acceptance lay a different form of control, one that sustained operations long after doctrine predicted failure. As the war extended and industrial capacity strained to replace losses, this logic gained weight. Fleets that maintained presence dominated those that burned bright and disappeared. Endurance shaped outcomes as much as firepower. In this light, the improvised engine fix was never about one aircraft. It was about recognizing that in systemic conflict, reliability multiplies effect far beyond any single engagement. By the end, manuals caught up only partially. Specifications remained. Limits were documented. But within units, practices reflected experience more than text. Engines were treated cautiously. Performance was moderated. The system adapted without announcement. History often credits invention. Less often does it credit restraint. Yet here, survival and effectiveness grew from refusing to force machines into failure. The engine that was allowed to run imperfectly kept flying. And because it did, the aircraft remained present in a war defined as much by continuity as by confrontation. In that continuity lay the real shift. Not a fix that made the engine better, but one that made the system more resilient. The laughter ended not with proof of superiority, but with the quiet accumulation of absence. Aircraft that did not fall silent. Engines that did not seize. Missions that did not abort. The war moved on. New machines arrived. Old lessons faded, but the pattern remained. Systems endure when operated with humility rather than expectation. The aircraft that flew when others could not was not an anomaly. It was a signal, one easily missed, one rarely celebrated, yet central to understanding how wars are sustained rather than won in moments. The engine fix was never just mechanical. It was cultural, and in the long arc of industrial war, that distinction mattered more than anyone admitted at the time. Operational pressure increased as campaigns extended and supply lines lagged behind demand. Engines were run longer between inspections. Crews worked with less margin and fewer replacements. Under those conditions, every assumption embedded in training was tested not in theory, but in repetition. Machines that required perfect conditions failed quickly. Machines that tolerated compromise stayed in service. The difference reshaped fleet readiness quietly, without orders or acknowledgement. Pilots assigned to these aircraft adjusted instinctively. They learned to listen rather than command. Throttle inputs became measured. Temperature gauges carried more authority than tactical impulse. Descents were favored over aggressive climbs. The engine was treated less as a weapon and more as a partner whose cooperation could not be coerced. This attitude had no place in formal doctrine, yet it proved compatible with survival, and survival accumulated influence. Squadrons began to diverge in character. Some pursued maximum performance whenever possible, extracting every ounce of power and accepting the attrition that followed. Others adopted a slower rhythm. Their aircraft moved with restraint. They did not always arrive first. They arrived consistently. Over time, the difference appeared in sortie rates and availability rather than in combat reports. Aircraft remained assigned instead of passing through replacement channels. Pilots built experience instead of being lost to mechanical failure. Maintenance crews noticed shifts that spreadsheets did not capture. Where patterns stabilized, failures became predictable instead of sudden. Engines showed signs of aging rather than catastrophe. Predictability allowed planning. Planning preserved momentum. In distributed theaters where loss of a single aircraft could disrupt operations for days, this mattered more than marginal gains in speed or climb. Enemy pressure acted as constant background noise. Interceptions remained dangerous. Anti-aircraft fire punished low-altitude flight. Nothing about restraint made war safer. It simply reduced the number of ways machines could fail on their own. That reduction compounded across operations, creating an imbalance difficult for opponents to detect or counter. Strategic planners rarely attributed success to such factors. Air power was analyzed through totals, not through absence. Yet absence told a story. Fewer emergency landings, fewer aborted missions, fewer losses attributed to mechanical causes. These trends were seen as improvements in logistics or production, not as outcomes of behavior at the cockpit level. The system absorbed the benefit without naming it. As newer aircraft entered service, the lesson repeated itself. Improved engines promised higher output and tighter tolerances. They delivered under controlled conditions. In combat, they still required judgment. Where restraint accompanied advancement, endurance increased. Where advancement encouraged excess, failures followed. The pattern persisted independent of technology. The initial engine fix receded into routine practice. What had once been an improvisation became habit. Power settings drifted lower than manual suggested. Cooling regimes were extended. Margins were protected deliberately. None of this contradicted engineering principles. It contradicted ambition. And ambition was easy to criticize when survival statistics lagged behind ideals. In reviewing operations long after, analysts pointed to airframe counts and production totals. They spoke of industrial capacity and strategic bombing. Less attention was paid to the small decisions repeated daily that kept individual machines operating. Yet those decisions shaped how effectively industrial output translated into presence over time. Aircraft that flew again exerted influence simply by existing. The laughter that greeted early restraint reflected a deeper discomfort. It challenged the belief that superiority must always be demonstrated. Accepting limits felt like concession. In reality, it established a different kind of control, one that valued continuity over display. That control proved resilient under prolonged conflict. As wars grow complex, such dynamics become decisive. Systems that survive stress outperform those designed only for peak conditions. The engine fix symbolized an understanding that war punishes perfection more harshly than imperfection managed. That understanding moved quietly through hangars and cockpits, altering outcomes without proclamation. Long after the specific machines were gone, the logic remained embedded. Reliability became an attribute cultivated deliberately. Maintenance practices evolved. Training adjusted subtly. Engines were no longer treated as expendable components to be driven until failure. They were preserved to maintain presence. The aircraft that flew when others did not win battles alone. It did something less visible and more enduring. It reduced friction between intention and capability. It allowed operations to continue when conditions eroded certainty. In a conflict defined not by isolated moments, but by sustained pressure, that capacity mattered profoundly. Eventually, history folded these lessons into broader narratives. They were attributed to industrial strength or strategic foresight, rarely to the quiet decision not to push harder. Yet beneath those narratives lay countless choices made far from command rooms. Choices rooted in humility toward machines and realism about limits. The engine fix stands as an example of how systems adapt under strain, not through breakthrough, but through accommodation, not by increasing demands, but by aligning behavior with reality. Such adaptations rarely receive credit. They do not announce themselves. They persist. In the end, war did not reward those who extracted the most from their machines. It rewarded those who kept them running. Continuity reshaped the balance more reliably than excess. And in that balance, the aircraft once dismissed proved its value not by surpassing expectations, but by redefining them through endurance. That endurance altered the tempo of operations in ways that were difficult to trace back to a single origin. Aircraft availability softened the edge between planning and execution. Commanders adjusted air cover assumptions downward across theaters where machines could not be trusted to remain operational. Where reliability held, those assumptions stayed intact. Missions stacked without interruption. Pressure accumulated without pause. The difference was not dramatic. It was relentless. Opposing forces responded to presence, not to theory. Aircraft that appeared repeatedly over the same zones forced adaptation regardless of performance specifications. Interceptions were scrambled. Fuel was burned. Crews were committed. Even when no engagement followed, the cost was paid. Sustained presence created obligation. Obligation drained flexibility. This dynamic favored machines that returned consistently rather than those that occasionally exceeded expectations. The fix itself remained unremarkable. No redesign, no new materials, no official endorsement. Its power resided in repetition and diffusion. Once mechanics incorporated it into routine practice, it ceased to resemble innovation. It became background behavior. That background behavior stabilized operations beyond any single airframe or squadron. As operational theaters expanded, the penalty for failure increased. Landing options narrowed. Weather imposed additional constraints. Spare parts traveled slower than demand. In such conditions, engines that tolerated suboptimal handling gained leverage, not through superiority, but through availability. A grounded aircraft exerted no pressure. An aircraft aloft, even imperfect, influenced planning on both sides. The contrast sharpened during extended deployments. High-output engines delivered short bursts of advantage. They also consumed themselves rapidly. Replacement cycles strained logistics. Training pipelines fell behind attrition. In contrast, aircraft managed conservatively accumulated flight hours instead of reports. Their pilots returned, adjusted, flew again. Experience converged with reliability, compounding effect over time. No official doctrine emerged to capture this shift. Institutional language struggled to describe absence as action. Planners preferred metrics anchored in achievement rather than preservation. As a result, the benefits remained undercounted. They persisted anyway. Systems absorbed them silently, just as they absorbed losses. Over successive operations, the psychological framing changed. Pilots began to expect their aircraft to last. That expectation altered behavior preemptively. Risk assessment shifted. Decisions favored continuity. The engine fix did not merely preserve machinery. It reshaped confidence in the platform itself. Confidence influenced engagement thresholds. Engagement thresholds determined exposure. Enemy analysis misread the pattern, interpreting restraint as limitation. They searched for weakness that was not there. Attempts to exploit perceived underperformance yielded little. The aircraft did not need to outperform. It needed to remain present. Presence denied uncontested space. That denial forced reaction. Reaction consumed resources. The longer the conflict stretched, the more dominant this quiet logic became. Wars of duration exposed design philosophies. Systems optimized for demonstration fade. Systems optimized for tolerance endure. The fix aligned behavior with the latter. It accepted degradation instead of resisting it. That acceptance preserved function. Eventually, the environment itself changed. New aircraft arrived. Engines grew more complex. Yet the underlying lesson persisted. Output without margin invited failure. Margin sustained operations. Though rarely articulated, this understanding informed later decisions indirectly. Engineers incorporated safety buffers. Trainers emphasized judgment. Maintenance cycles adapted. What began as ridicule transformed into silence. Not approval, not recognition, just absence of dispute. The practice continued because it worked. Aircraft returned. Missions were flown. Pressure remained. In post-war analysis, the focus shifted elsewhere. Air power narratives favored scale and production. Individual behaviors vanished into aggregate statistics. Yet those statistics rested on countless small choices that protected function over spectacle. The engine fix belonged to that category. It did not redefine aviation. It preserved it under stress. Such preservation rarely earns credit. It lacks drama. It produces no sudden turning point. Its effect unfolds gradually, measurable only by what does not happen. No failures, no interruptions, no collapse. In systems under sustained strain, that restraint shapes outcomes as decisively as any breakthrough. The story is not about mechanical modification. It is about alignment between expectation and reality. The moment when performance ceased to be pursued blindly and began to be governed was the moment capacity stabilized. That stabilization altered the balance quietly, without proclamation. The aircraft that flew when others could not did so because limits were respected. That respect translated into time. Time translated into presence. Presence translated into pressure. And pressure, sustained without interruption, reshaped the operational environment more reliably than any single act of heroism ever could. That pressure did not announce itself with visible markers. It operated below the threshold of recognition, altering patterns rather than outcomes in isolation. Missions overlapped without interruption. Aircraft cycled through sorties with minimal variation. The airframe became a constant rather than a variable. Commanders began to plan around that constancy, assuming availability instead of contingency. This assumption narrowed uncertainty. Where uncertainty narrowed, operational tempo increased. Requests for air presence grew more confident. Timetables tightened. The machine's continued function reduced the need for excess margins elsewhere. Escorts launched on schedule. Reconnaissance windows held. Bombing sequences aligned with ground movement rather than waiting on clearance. None of this traced back to a single report. There was no directive stating why reliability had improved. The system simply adjusted to observable results. Aircraft that returned repeatedly became trusted implicitly. Trust removed friction. Friction was the enemy of sustained pressure. On the opposing side, that continuity distorted assessment. Analysts searched for technological signals that explained the increased persistence. They examined engine outputs, airframe design, fuel composition. The explanation did not appear. There was no marked escalation in capabilities. What changed was tolerance. Tolerance for heat. Tolerance for handling variance. Tolerance for extended use. Without recognizing this shift, opposition planning overcorrected. They committed resources to intercepts that yielded no decisive engagement. Fighters scrambled to challenge aircraft that did not oblige by overcommitting. The pursuit burned fuel and time without delivering resolution. Absence of engagement did not equate to absence of cost. The fix remained invisible because it produced consistency rather than advantage. Advantage invites imitation and response. Consistency erodes opposition gradually. It transforms contested spaces into occupied routines. Over time, routines become assumptions. Assumptions restrict options. Within maintenance crews, the practice normalized. New personnel absorbed it without explanation. It became procedure, not innovation. Deviations were avoided not because of regulation, but because outcomes spoke clearly. Engines treated conservatively survived. Engines pushed aggressively failed earlier without compensatory benefit in most scenarios. This behavior aligned individual incentive with systemic resilience. Pilots who returned flew again. Crews with intact aircraft maintained operational relevance. Losses carried reputational weight. Reliability became a professional virtue rather than a technical attribute. As conflicts extended, attrition shifted focus from performance peaks to operational stability. The machine that remained usable defined the pacing element. It filled gaps others could not. It substituted reliability for superiority and found the exchange favorable. In later stages, intensity increased elsewhere. New threats emerged. Countermeasures evolved. Yet the underlying pattern held. Where systems respected limits, function persisted. Where limits were ignored, collapse arrived unpredictably. The fix did not prevent failure categorically. It reduced its frequency to manageable levels. By the time broader recognition might have occurred, the context had moved on. New technologies absorbed the lesson indirectly. Safeguards became standard. Operating envelopes widened through caution instead of force. The original source of a shift faded into background noise. What remained was the outcome. Aircraft available when needed. Missions executed without delay. Pressure sustained without interruption. These effects compounded quietly, shaping the operational landscape. In conflicts defined by duration rather than climax, such behaviors determine success more reliably than innovation alone. The ability to continue becomes decisive. The engine that endured exemplified this principle through restraint. And so the laughter faded not because it was disproven publicly, but because it became irrelevant. The aircraft flew. Others did not. Over time, that difference required no explanation. That difference accumulated across cycles rather than moments. Each uninterrupted sortie compressed planning windows elsewhere. Ground units adjusted expectations upward, not because of promises, but because presence had become dependable. Air cover ceased to be requested conditionally. It was assumed. Assumption hardened into doctrine without ever being written. This quiet shift altered decision-making at every adjacent layer. Logistics synchronized with predictable return intervals. Intelligent schedules aligned with anticipated coverage rather than contingency gaps. The rhythm of operations stabilized, even as intensity increased. Stability did not suggest calm. It suggested control. Opposing forces sensed this control indirectly. They encountered aircraft that appeared without warning and withdrew without strain. Intercepts became obligations rather than opportunities. Engagements produced ambiguity instead of confirmation. The absence of decisive encounters denied feedback. Without feedback, adaptation slowed. Attempts to force engagement exposed the asymmetry further. Fighters pressed harder, extended longer, accepted narrower margins. Mechanical strain rose unevenly. Losses occurred without proportional gain. The contest drifted away from sharp exchanges toward persistence contests that favored whoever could remain active longer with fewer resets. Nothing about the engine fix projected dominance. It offered no burst, no dramatic edge, no visible signature. It removed a failure mode. Removing failure reshapes systems more profoundly than adding power. Power invites challenge. Absence of collapse frustrates it. Within operational culture, credit diffused. No single figure received lasting attribution. The modification blended into routine. Its origin mattered less than its effect. That anonymity protected it. There was nothing to target, nothing to counter directly. As months passed, the pattern reinforced itself. Aircraft availability dictated planning confidence. Confidence enabled tempo. Tempo constrained enemy choice. The feedback loop closed quietly and held. Later assessments struggled to isolate when the balance shifted. Analysts marked campaigns, weapon systems, leadership changes. The subtle continuity escaped timelines. It did not spike. It endured. The lessons surfaced only indirectly, embedded in later manuals through phrasing about margins, tolerance, sustainable output. Design philosophy bent toward longevity. Operators learned to value engines that lasted over engines that surprised. Reliability became force multiplication without ever being named as such. In environments where collapse and participation entirely survival is not neutral, it changes the geometry of conflict. The aircraft that could always fly redefined what control meant. Not dominance in the air for a moment, but denial of escape from pressure over time. The fix never needed validation. It functioned. That was sufficient. That function carried forward without ceremony. Crews rotated. Commanders changed. The aircraft remained. Its persistence outlasted individual judgment and compensated for structural uncertainty elsewhere. When plans strained, the assumption of return remained intact. That assumption altered risk calculations more reliably than any briefing. Opposition forces adjusted in fragments, reacting tactically without resolving the underlying constraint. They experienced encounters that refused resolution. Pursuit yielded no collapse. Waiting produced no absence. The sky became occupied without being contested in traditional terms. Control expressed itself through continuity rather than confrontation. This continuity imposed cognitive pressure. Every sortie implied the next. Every appearance suggested permanence. Enemy planners responded by widening safety margins, lengthening preparation, deferring action until certainty arrived. Certainty did not arrive. Delay became the default state. In prolonged conflict, default states matter more than decisive moments. They shape resource expenditure, pilot fatigue, mechanical depletion. They determine which systems degrade first. The engine that did not fail forced everything around it to absorb the cost of adaptation. The fix did not win battles. It prevented losses that would have reshaped trajectories. It allowed operational threads to remain unbroken. Unbroken threads define campaigns. Long after urgency faded, the pattern remained visible to those looking backward, not as a breakthrough, not as innovation, but as the point where collapse stopped occurring. The moment failure ceased to be expected, strategy recalibrated itself around endurance. War rewards outcomes that survive scrutiny after noise recedes. In that silence, what mattered was not who was mocked, or who doubted, or who laughed. What mattered was which machine kept returning when others eventually could not. That difference accumulated quietly, not as a statistic, not as an official acknowledgement, but as an operational reality that imposed itself on every subsequent decision. Missions began to assume survivability as a baseline rather than a gamble. Aircraft allocation shifted accordingly. Routes extended. Timelines stretched. Confidence did not rise sharply. It stabilized. Stability changed behavior. Crews prepared differently when the expectation of return was no longer fragile. Maintenance cycles aligned around continuation rather than recovery. The aircraft ceased to be treated as a consumable bound to a single sortie. It became a reliable instrument within a system that depended on repetition. Opposing forces interpreted this persistence through familiar lenses and found no clear explanation. Encounters did not escalate into resolution. Attrition did not follow contact predictably. The absence of failure became an anomaly harder to address than overt strength. Planning models faltered where disruption refused to occur. This created a form of pressure distinct from confrontation. Not the shock of loss, but the strain of inability to force change. Every attempt to provoke breakdown encountered the same outcome. The plane returned. The pattern repeated. Tactical variation yielded no decisive shift. Over time, this altered the tempo of the wider conflict. Operations slowed where certainty could not be manufactured. Resources diverted toward contingencies that never triggered but could not be ignored. The cost appeared diffuse, spread thinly across time, but it persisted. In such environments, endurance outweighs spectacle. Systems fracture not from singular blows, but from sustained imbalance between expectation and reality. The aircraft that continued functioning imposed that imbalance relentlessly without announcement. No doctrine formed around it first. No narrative crystallized. The change resided in absence. Absence of loss. Absence of collapse. Absence of forced adaptation on one side and continual reactive adjustment on the other. Eventually, the distinction clarified itself in hindsight. Some machines define moments. Others define conditions. This one defined a condition in which failure stopped being routine. Once that condition existed, strategy followed. Not because it was celebrated, but because it could be relied upon. In war, reliance reshapes intent more quietly than admiration ever could. And when the long arc of the conflict is examined without urgency or sentiment, the significance lies not in the fix itself, but in what it removed from the equation. It removed inevitability. It removed decay. It removed the silent countdown that governs all temporary solutions. What remained was persistence. And persistence, sustained long enough, alters outcomes no one planned to change. Persistence reshaped the environment in ways that were not immediately measurable. The absence of catastrophic failure forced planners to confront a new baseline where assumptions about attrition no longer aligned with experience. Forecasts became cautious. Projections grew layered with contingencies. The system adjusted not because success demanded it, but because collapse no longer arrived on schedule. As this condition stabilized, its influence spread laterally. Supporting units calibrated effort against continuity instead of replacement. Logistics began to privilege sustainment where once they prepared for loss. Training emphasized conservation of capability rather than expenditure in pursuit of decisive moments. None of this required formal acknowledgement of cause. The pattern made itself useful, and usefulness embedded it deeper into routine. Opposition responses followed a different trajectory. Without clear signals of degradation, pressure had nowhere to concentrate. Escalation produced movement, but not effect. Repetition replaced experimentation, and repetition without yield generated friction inside the opposing system itself. The difficulty was not defeating the aircraft, but predicting when and how effort would matter. This friction did not erupt. It accumulated. Resources remained committed to a threat that refused to peak. Attention stayed locked on an object that did not break. Over time, this produced a subtle inversion. The plane no longer reacted to the environment. The environment reacted to the plane. Such reversals rarely announce themselves. They exist first as inconveniences in reports, then as discrepancies in planning meetings, and only later as recognized shifts in operational balance. By the time they are named, they have already dictated behavior for an extended period. The aircraft's continued function diluted urgency. Without dramatic signals, priority systems struggled to escalate response. Other demands pressed forward. The threat became persistent but non-critical, dangerous but unresolved. That ambiguity proved difficult to discharge. In this space, time exerted a different authority. Each uneventful sortie reinforced the same message without articulation. Survival was no longer exceptional. It was expected, and expectation, once normalized, alters the structure of risk itself. Risk, redistributed in this way, ceased to concentrate around the machine. It dispersed across the opposing network. Every decision now bore a share of unresolved tension. Each adjustment attempted to resolve a problem that refused to present a final shape. The engine modification remained invisible in this process. It did not announce its role. It did not draw recognition. It simply withheld failure. And by withholding failure consistently, it removed a cornerstone upon which counteraction depended. War often rewards disruption that is loud and brief, but it also responds to disruption that is quiet and sustained. The latter is harder to isolate, harder to correct, and far more difficult to confront directly. As operations continued, the system adapted around what did not change. The aircraft flew. The engine held. The sortie returned. Each cycle reinforced the same equilibrium. And equilibrium, maintained under pressure, becomes leverage without ever appearing to be one. That leverage altered expectations without rewriting doctrine. Plans assumed endurance by default. Contingencies accounted for persistence rather than disappearance. The notion of sudden absence, once central to risk modeling, slowly lost urgency. Failure became something to prepare for in abstract terms, not something that defined timelines. Within this framework, decision-making decelerated. Urgency diffused across layers of review. Actions that once promised resolution now produced only maintenance of the existing condition. The environment adapted to stability rather than reacting to threat. This did not signal control, it signaled accommodation. The aircraft's presence no longer demanded immediate countermeasure. It demanded management. Management consumes attention differently. It requires scheduling, monitoring, allocation. These processes do not culminate. They persist, and persistence, when imposed externally, drains focus from elsewhere. Nothing about the engine fix carried intention beyond function. It did not impose dominance. It did not invite confrontation. It simply prevented collapse. That restraint proved decisive. By denying the opposing system a predictable failure, it denied it relief from uncertainty. The longer this pattern endured, the harder it became to classify. Analysts searched for indicators. Commanders searched for moments of change. Neither arrived. The aircraft continued to operate within expected parameters. The environment adapted around that expectation, mistaking stability for stasis. Yet stasis was not what emerged. The parameters themselves shifted. Thresholds recalibrated. What had once been considered a critical window became routine margin. What had once justified extraordinary response settled into background requirement. Pressure redistributed again. Supporting elements bore greater share. Surveillance increased. Interdiction broadened. Each adjustment diluted intensity without resolving origin. The system responded as if the problem lay elsewhere, because the object at its center refused to behave as a problem. Over time, this misalignment became structural. Resources were spent sustaining readiness against an outcome that did not materialize. Readiness, prolonged without discharge, transforms into fatigue. Fatigue alters judgment subtly. It does not announce itself. It appears as delay, as caution, as recalibration of what matters most. In this environment, the aircraft's continued operation exerted influence disproportionate to its apparent role. The fix was small, local, uncelebrated it. It did not redesign the aircraft. It preserved it. Preservation proved more disruptive than innovation would have been. Innovation invites response. Preservation normalizes presence. As the system absorbed this normalization, its reactions lost sharpness. The threat no longer demanded precision because it no longer promised conclusion. Forces adjusted posture, not intent. They waited for a peak that never formed. War does not require effect to be visible in order to be decisive. Effect can reside in the removal of expected endpoints. When failure is anticipated and does not arrive, the framework built around that anticipation erodes. The aircraft remained. The engine endured. The cycle repeated. And repetition without resolution shaped the landscape more decisively than any single event could have. That landscape hardened into norm. Operations no longer revolved around eliminating the anomaly, because the anomaly had ceased to present itself as one. It functioned. That was the difficulty. A system is designed to resolve exceptions, not to accommodate continuity under conditions that predict breakdown. When breakdown refuses to occur, escalation loses justification. This was not a failure of response, but a saturation of logic. Every evaluation assumed eventual degradation. Maintenance cycles, sortie expectations, attrition forecasts all depended on the premise that endurance had limits that would reveal themselves under pressure. The engine fix displaced that premise just far enough to keep those revelations from arriving on schedule. No official adjustment followed. None was required. The system compensated quietly. Margins widened. Timelines stretched. The absence of collapse was absorbed as data without triggering conclusion. In that absorption, agency diffused. Responsibility moved upward, then outward, until no single layer claimed ownership of outcome. What endured was not the aircraft alone, but the condition it imposed. A condition where engagement produced continuation rather than decision. Each encounter extended process instead of ending it. That extension altered the meaning of success. To continue was to succeed. To disrupt was to influence. To persist was to deny clarity. The engineering logic behind the fix never appeared in strategic discussion. It did not need to. It generated no doctrine. It generated behavior. Behavior repeated becomes environment. Environment shapes assumption. Assumption governs reaction. Eventually, reaction narrowed. Movements shifted from proactive to anticipatory. Anticipation without event weakens resolve. Not through fear, but through normalization. The aircraft did not force confrontation. It removed urgency. In war, urgency sustains coherence. When urgency fades, structure remains, but intent fragments. Units continue to operate, but their actions aim toward maintenance rather than outcome. That distinction is subtle yet decisive. The engine fix did not win engagements. It postponed endings, and endings postponed indefinitely cease to function as goals. Systems require closure to update. Without it, recalibration stagnates. What persisted was not advantage, but imbalance. An imbalance between expectation and reality, maintained long enough to alter strategic posture without declaring change. The aircraft was not stronger than its peers. It was simply present when absence had been assumed. And presence, sustained under the wrong assumptions, reshapes war not by force, but by refusal. That refusal operated beneath notice. It did not announce itself through victory claims or altered manuals. It revealed itself only through duration, through operations that were supposed to end and instead extended, through pressure that failed to peak, through engines that continued to run inside envelopes where stoppage had been forecast. Over time, that duration accumulated weight. Systems trained to react to loss found none. Forecasts adjusted incrementally, then halted, not because accuracy was achieved, but because deviation no longer triggered correction. The anomaly became background. In that background, the meaning of reliability shifted. It was no longer a characteristic measured at the edge of performance, but a factor that quietly redrew acceptable risk. Missions were flown slightly longer. Margins were consumed without comment. The absence of failure migrated from surprise to assumption. Assumption is where doctrine rests. Yet doctrine requires contrast to remain visible. When contrast fades, doctrine ossifies. It continues to exist, but responds more slowly to conditions it no longer distinctly perceives. The engine fix remained unnamed. It circulated through maintenance language, through informal briefings, through repeated outcomes that resisted classification. Its logic was simple. Its effects were not. By removing a predictable point of collapse, it displaced the timeline upon which decisions depended. Command structures respond to endpoints. They escalate, reinforce, redirect. When endpoints blur, command pauses. Not consciously, procedurally. Decisions defer to monitoring. Monitoring replaces action. That replacement altered tempo. Not dramatically, sufficiently. Tempo is cumulative. Adjusted fractionally across enough operations, it reshapes campaigns without ever being ordered to do so. The aircraft kept flying. Others followed established curves. Planning assumed convergence. Convergence did not occur. In that gap, initiative redistributed. Not toward bold maneuver, but toward inertia. The side that could continue without demanding resolution gained space to operate within the opponent's unanswered questions. No breakthrough arrived. None was required. The fix did not break systems. It suspended their expectations. And suspension, sustained over time, became influence. The war continued. Objectives remained unchanged on paper, but the rhythm underneath shifted. Actions were taken later. Reactions softened. The moment where change was supposed to happen passed quietly. That is how technical decisions alter conflicts. Not by rewriting plans, but by surviving where plans predict failure. Not by creating advantage, but by removing certainty. The engine fix was never strategic. Strategy simply adjusted around its persistence. And by the time that adjustment became visible, it had already set the conditions that made reversal unnecessary. What followed did not register as a turning point. It never appeared in summaries of decisive moments. No single operation carried its name. Instead, its presence can only be understood by widening the frame, by stepping back from the immediate mechanics of flight and repair and placing the episode inside the longer arc of how industrial war adapts to its own pressure. The conflict had reached a phase where technical systems no longer failed dramatically. They failed statistically. Attrition did not arrive through catastrophe, but through accumulation. Engines that stopped slightly sooner. Aircraft that remained grounded marginally longer. Crews delayed by processes that assumed breakdown as a norm rather than an exception. In such an environment, any intervention that altered reliability did more than improve performance. It changed the assumptions upon which tempo, logistics, and command timing were built. This was not a matter of speed or power in isolation. It was a matter of continuity. Modern war depended increasingly on uninterrupted sequences. Patrols layered onto patrols. Escorts stacked upon escorts. Plans assumed that a certain portion of machines would not return, not because of enemy action alone, but because systems were down. When one element refused to conform to that expectation, the discrepancy did not announce success. It created distortion. Schedules drifted. Reserves accumulated and used. Commands waited for losses that did not materialize, then hesitated when they still did not arrive. Over time, that hesitation propagated upward. Operational planning relies on predictive decay. When decay stalls, projection loses sharpness. Decisions are delayed, not out of caution, but out of uncertainty. The enemy is still present. The objectives are unchanged, yet the conditions that once justified acceleration no longer align. War does not stop, but it slows in places where speed was assumed. This is where the broader significance emerges. The engine fix mattered not because it granted dominance in combat, but because it interfered with the logic of attrition itself. It denied predictability to both sides, but it favored the side capable of absorbing unpredictability. Industrial warfare rewards systems that remain functional under ambiguity. Reliability becomes a strategic resource, even when it is never labeled as such. In retrospect, this episode illustrates a recurring pattern of the conflict. Victory was rarely delivered by singular innovations alone. It emerged from countless small corrections that allowed systems to persist longer than anticipated. Mechanics, engineers, and crews operating far from strategic debates reshaped the war simply by refusing collapse at prescribed points. Their work did not overturn doctrine. It quietly forced doctrine to adapt. Seen at scale, the war was not only a contest of weapons, but of expectations. Expectations about failure rates, about timing, about when pressure would produce results. Any deviation from those expectations, sustained long enough, altered planning more effectively than direct confrontation. The engine fix belonged to that category. It removed a certainty rather than introducing a capability. When historians later trace the flow of the conflict, they often search for moments of clarity. This was not one of them. Its influence lies instead in the gradual redistribution of confidence and doubt within complex systems. Aircraft that kept returning shifted burdens elsewhere. Choices made under conditions of assumed breakdown had to be re-examined. The war absorbed the change without ever naming it. That is why this story resists neat conclusion. It does not end with a mission accomplished or a doctrine rewritten. It ends with persistence becoming normal, and normality quietly rewriting the mathematics of endurance. In a war defined by industrial scale and sustained pressure, that was enough. The plane flew when others could not, and in doing so, it demonstrated that survival, extended over time, could shape outcomes as decisively as any visible triumph.